Oh, and there we are.
Hello.
I think this is working. Hello, everybody. And
Nice.
welcome to another InSession.
Number 23.
Number 23 today with Anna. Thank you so much for joining.
Yeah.
Hello.
We're really thrilled to have Anna, Dr. Anna Herruzo.
Mm-hmm.
And I'll give a very, very, very short introduction because it could be very long. But Anna is trained as an architect, interactive designer, and she's also an educator working in emerging and computational media. Anna's focus is on the incorporation of lighting, audio, and video with the physical environment and human interaction. And also, I do want to mention that Anna has been a cornerstone in the TouchDesigner community since 2011, both as a practitioner and as an educator. So there's more. Welcome, Anna.
Thank you so much for having me here today. I'm so excited.
You're joining us from ASU, Phoenix, Arizona.
Yes, exactly, at the new Media and Immersive Experience Center.
Exciting. We're going to talk a bit about that later as well because, that's kind of one of your, you were involved in bringing it to be.
Exactly. Yeah, I've been here for a year and a half, and the center opened in August, and we're launching these 3 new grad programs and research facilities. And yeah, we'll get into it later on.
But anyway, we were talking earlier, and you first encountered TouchDesigner when you joined Obscura Digital in 2011.
Yes, at the end of 2011, I joined Obscura Digital, and we were at their office in Potrero, at the Dog Patch in San Francisco. And it was part of what we called at the beginning the interactive team. There was the media team and then the interactive team, and then I just have to dive into TouchDesigner. I think it was 5 months later I was running domes already. Wow. For NASA, we had this NASA tour, and I was doing it in New York at the Intrepid, so I had to learn pretty fast.
Can I ask what your background was because then that means you joined that was your first exposure to TouchDesigner then?
Yes, so my background was architecture, so I already had master's in architecture, but I really wanted to work since 2005 when Arduino started, and processing all the open source. I was really interested in interactive environments and how humans could interact with the environment and help design it as well. So moving architecture a little bit forward and interacting with the space. And I found a master's in architecture school in Los Angeles called SciArc, and they had a media arts program. And I came here to do it, and then I learned, processing, etc. That's what you were doing in those years, but also Maximus B. And I tried to do projection mapping with Maximus B in 2010, and it was just very difficult.
Go ahead.
Yeah, and then when I went to Obscura, I started learning TouchDesigner. I was like, oh my god, for graphics, it was just, it blew my mind.
So SciArc, Mary Frank was there too, another of your colleagues at Obscura.
Yeah.
So I remember visiting SciArc, which was really impressive. I mean, it was a really good school.
Yes, Mary joined after she left Obscura.
Okay.
Actually, it had to do with us being friends and her going there. Yeah, and it was a great experience for her too.
Yeah, SciArc is really
Greg, you're muted.
SciArc is the amazing places. There's a long corridor of projects being reviewed on the fly kind of thing, and the students really exchanging know-how very fluidly there. And I know there's kind of a robotics lab in there as well.
Exactly. So the year that I started there, the robots appeared, and nobody knew how to use them. And actually, my colleagues John and Brandon, who joined Bandali later, figured out how to move these robots, and we put some projectors on it, and we did some audio and visual projects with those robots. And the cool thing about SciArc was that it was a very large warehouse. You've seen it, and all the students would just cross from one side to the other, skateboarding, and you could do anything you wanted. So with the space, so I remember for my finals, I would just drill holes on the wall, put projectors up, and it was a great environment for creation and creativity.
Yeah. And it was also sort of like a perfect kind of place for things to spread like viruses, and I mean ideas, not germs. That happened later, but that was sort of kind of the impression that you got, that things just kind of spread through the space, and super cool.
And at the time, the Arts District in downtown LA was amazing, and it was just a perfect place to be.
So you've basically been around for a lot of interesting beginnings, right?
Yes.
ChatGPT, which
yeah.
But right now, the beautiful thing we're looking at is the first project that I wrote about for our showcase, Captured Atmosphere, and that's with your partner in Naive Laser. Really beautiful piece that you sort of built the whole sort of smoke delivery system. And do you want to tell us a bit about this one?
Yeah, so Jenny and I were collaborating with Julieta Gil as well, and we got this grant for a Paseo Arts Festival. And I had just left Obscura. I had been working with projectors for many years, large-scale projection mapping projects. And I was like, I want to try lasers, and I thought it was going to be pretty easy. Naive. Therefore, that's why we call ourselves Naive Lasers. And because, I ordered this laser from China, and then we got this project, and then we realized we couldn't use it. It was not legal. It didn't have a variance, and we started realizing all this technical, we basically opened a can of worms. And then, we figured out that lasers do not take pixels. I just hadn't thought it through. I was like, I just want to do this.
No pixels.
And then we started going into TouchDesigner, and we could only use the pattern chop at the time, and I remember, right? And but then we just started playing around. I got a second laser that did have a variance. We had Jamie had a ceramic studio in Alhambra, like a warehouse in LA. So all these things were happening there, all of our tests. And we wanted to interact with smoke and different materials with the lasers and find ways to synchronize them. That's why we ended up building this pipe organ that had 5 different smoke machines, tiny smoke machines that could fit. So we were also running them through DMX. We used a custom board, so that we could run DMX from TouchDesigner into these tiny machines and try to figure out ways that we can synchronize these pipes with different visuals. And also the hardest thing was to make the laser super smooth and not tiring to the eye, make these experiences and the graphics. So I worked a lot on all these animations to make them slow, and it took work. But it was a beautiful project. We enjoyed it a lot, and we laughed a lot, and therefore we said we have to start a collective and call ourselves Naive Lasers, because we were so naive about this.
It's kind of how we started with lasers as well. Rob Barros kind of started this with trying to put images on an oscilloscope.
Yeah.
And then the next step was
no pixels as well.
Next step was to get a laser from eBay from China. Burn a couple holes in a few jackets, and then go from there.
Yeah, I'm pretty sure Malcolm helped me with some things at the time. But I remember there was Team Geyser that started doing something, and but there was hardly any documentation on it when we were trying to do these things. And
pioneering work.
But what we really try to do is those images, we were trying to recreate natural phenomena, and those are some of the images that you have on your blog that kind of with the smoke and different
lightning
materials. We were just blown away by the reflections on the transparent tubes and how it would shine on the rooms, and working with the smoke. It just was it was very, I really enjoyed working on this project.
It worked out absolutely beautifully, honestly. It's still one of my favorite laser projects.
Oh, so glad.
Yeah, almost 8 years later. Am I skipping?
No, 2016, almost. In September, it will be 7 years.
I'm going to try, sorry everybody, I'm going to try to adjust the volume here a little bit. Hopefully we can get the clipping out. It's not clipping for me, but something seems to. So,
is it clipping for everybody?
Yeah.
Anna, maybe you can tell us about your PhD. while we're clipping.
Okay, okay. So, and that has to do with the Getty project as well, the Getty project that you also wrote a blog post about. But my PhD is mainly on ethics in media arts projects. So I try to look at how artists should have accountability for the work that we do when we're working with new technologies. And specifically, I look at the fields of entertainment, art, and architecture, and mainly projects that work with AI, computer vision, and the main topics of research are issues of surveillance, privacy, and bias. So when we're using computer vision or we're using people's data, and sometimes our projects could maybe invade people's privacy or end up perpetuating biases, and we are different from other corporations that are actually developing all of these technologies. They sometimes, are looking for profit. Artists, we're not in general, so we think that we maybe cannot incur in these issues, but we do. So the idea is to work on that accountability, acknowledgement, and decision making in our practices.
That's great. Really important.
Amazing.
Yeah, I mean, I don't want to open up another can of worms right now, but I mean, today this is such a really, really massively important thing to have driving your practice.
Yeah, and I also try to bring it to the curriculum and the university. So part of my dissertation also, because I used to run a program at Woodbury University. It was called the Applied Computer Science Media Arts, and I worked on developing a whole Bachelor of Science curriculum in our field. And I realized when I was doing my PhD, I was looking at all the classes that we made, and there was no ethical course or learning outcomes within these classes where, interactive prototyping, for example, right? And we're working with Internet of Things and looking at the actual, academic syllabus. I couldn't find that many learning outcomes, so I try to raise awareness on that as well, and how we can bring it, now that I'm in ASU, bring it to our programs and make sure that when we teach how to use these technologies for artistic or creative environments, we also acknowledge ethical implications that they can have.
Wonderful. Great. We'll go back to ASU, but let's take a little detour to Manhattan, 85 Broad Manhattan.
Okay. I wanted to show this project that I working with ABNC and ESI Design. I work as the main TouchDesigner developer for all of these installations and 85 Broad, which is in the historic district of Manhattan. So the project consists of several sculptures, an archway outside, and also some transparent LCD screens that are projected over those beautiful milled wooden maps of Manhattan. And so everything is synchronized, it's real time, there's real-time data visualizations on those screens going on, everything is pinging APIs, and see there we can see right now how the maps overlay, the transparent screens overlay with the maps. And I think since my background, like what Marcus asked before, is architecture, I really enjoyed working on this project because they did an amazing work at ESI, integrating the architecture with all these media elements. And that's part of my line of research right now at the Mix Center. So I wanted to showcase this project, which was done in 2016, and tie it into the mission of the new building of the Mix Center, and what I'm doing here. What we see right now is like some Twitter animations that we're grabbing feeds of what was being tweeted the most around the neighborhood and around the building. So those hashtags were going on those arches outside, and it's still running successfully. It's been several years. So there we have TouchDesigner, a stable playback system running since 2016.
Thank you.
Good. That's great.
Wow. So if you're in New York, 85 Broad.
Yeah, stop
Right.
by.
And that was basically a renovation, right? So they didn't have much
Yes.
leeway what they could do. They had to stay within pretty tight parameters to do that.
Also, it's a historic building. So on the other side, there's two arches. One they get connected by that pathway that has that sculpture in the ceiling. And so this archway here, which is in Broad Street, we could project content, but on the other one, because it's a historical plaza, they didn't let us, and at the end we have to leave it as a light. So it is tricky what you can display on these public environments in these districts.
Yeah.
And yeah, it was the development company is called Beacon Capital, and they're a development company that buys these large buildings and are renewing the lobbies to make them more enticing for the users and the inhabitants.
So how does this tie into the Mix Center? You said this is kind of what you're developing there.
Okay, so if we can go to directly to Mediated X.
Let's do that. Mediated experience.
There we go.
There we go.
So that's the new Mix Center in Mesa, Arizona of ASU. So it's been designed to have a facade that has LEDs and a large jumbo screen. It's a 90-feet screen, and it also we also have in the lobby it's like 30,000 K large screen, tile screen. And the idea is to make this building it's a media production center. We share also with the film school. And the idea is to make this building as interactive or communicative as possible. That's my mission and my research environment. Tying also to my architectural background, what I'm working on right now is how can I create, because all of these systems have been implemented, standard. The lights, all the LED fixtures are not, programmable. There's just like some patterns that we can load. Software right now the servers just go directly to the jumbo screen. Nothing is interactive. Nothing is custom. So we are working on how to synchronize the whole building, and we've been speccing the systems. And last year, remember, I was teaching a class on how to make playback systems to make a large playback system to control the whole building. And three of you were part of the midterm review of our students.
Yes, we reviewed some of your students' work. Yeah.
Exactly, it was super exciting.
Great.
So we're still working
stars.
on developing. Exactly. So, yeah, and the mission is to use all these, because people sometimes they don't realize the difference. There's a big difference from having a standard setup just that can just play some patterns on those fixtures and those screens, to have like what I'm building right now, a weather station where we can grab data and make the whole building react to it, right, and be alive. And there's a huge step of work and development that has to go into going from one standard setup to an interactive and customizable research system. That is what we're working on right now.
So do the students jump right in? I mean, sorry, just one quick question. Or is there any kind of scope scare, or when they encounter the space and all the possibilities, like how do your students kind of react? What's their first reaction?
So what we have, the building is pretty, right now, it's pretty just as the architects designed it. So we're also teaching a class with Jake, the director of the center, called Remix, and that
Jake
class is... Yeah, Jake Pickelholster, and which I should be teaching right now. So I'm wondering if they're watching it in class right now, because it's going on. I'm skipping class right now to do this, and we're teaching. The students are pitching different installations that to activate the building in different ways, and there's a budget for that. So the idea is to start making it more personalized and more relatable to the users of the space.
Very nice. Marcus, you were going to say?
Oh, it's just a question from the chat here. There was the reference to the 30K video screen, and do you have any insight on what kind of a computer you had to run this?
So I spec'd, so we have to use Dell servers with ASU, and I spec'd them a year and a half ago. So I spec'd some RTX A6000s Quadros. We're working with that so that we can output one full screen, and and not have to deal with tearing issues, etc. So that's what I don't remember the processor right now, but that's our card. So it's not a cheap at all setup.
No.
Oh, it's a big building.
So Playful Pixels, we love the name, and that was one of the first projects you did with your class not the white cells, but
Yeah. So for the opening of the Mix Center, that was in October, mid-October. So there's what we call the Enhanced Immersion Studio, and it's a 60-foot by 60-foot by 60-foot large black box with a catwalk with different trusses, and it's like a creativity environment to do productions. And they wanted us to activate it. So staff of the building asked me if I could activate it for the opening. So I worked with 2 students, Xavier Noakes and also with Henry Beach, which they're possibly watching this right now, and also with Paul Mendola, who's the technical director for that space. And that's Henry and Xavier working on the project right there. And the 3 of us activated, and we made Playful Pixels and for this opening. So at the moment, we had limited infrastructure. We just had one Azure. We're still buying gear for the building. We had one Connect, and we had 2 projections, and we didn't have time to work on the blending. So what we did is that we created one projection that was interactive, and the users were being tracked, and on the other screen, on the other projector, we had the inverse, which didn't have any tracking. So that's why we called it Playful Pixels, because in the end, people were trying to figure out where they were being tracked and where not, and what was happening. And it was a huge success with the kids and the visit. It was an open house, so we had tons of people come into the building that day, and all the content was created by Henry and Xavier. And then Henry and Xavier were taking a class called Immersive Experience Design that I was teaching with co-teaching with Wadey Zhang, who's also an amazing touch designer artist. And so what we did is we brought the project to the class, and we decided to use it for the final of the class and expand it into a larger collaboration with all the students called MELT. And now we had a concept about, the students came out with a concept of climate change, and they wanted to integrate different immersive experiences. So we expanded it to be like a full floor projection, figured out the blending, calibration. We added 4 Azures. We calibrated them as well, which was pretty tricky since, the camera, it's a wide angle point of view, so it was pretty hard to get those 4 cameras to match in the middle, to do the blob tracking. And then some of the students did some AR experiences. They created custom AI experiences with markers on the floor, and it overlaid with the projections on the floor. And they had a voiceover, and it was talking about different climate change issues. It was pretty interesting, and people really enjoyed it. And we also had because we had some software developers in the class, we created a web interface on the iPad, and you could trigger different animations and also learn from different climate issues. So it was also interactive. We have a web portal, AR, CMS, and large floor projection. So
like how do you divide the work between, or divide the work between all your students, because they're all working on different kind of things. Infrastructure, tracking, blob tracking, and then applications, and then the art part and all that kind of stuff. There's a lot of things that are thrown together into this, and they're all learning different things, but they're also learning from each other.
Yeah, so it's a tricky. The thing is that since Henry and Xavier have taken my class last semester, building the playback systems, and also the Urban DX data visualization class, so they were pretty, experienced, and we also developed a whole system for Playful Pixels, so we had like a good starting point. And then we had, so what we do is look at the skills that the students have. This is an introductory class, and we have students from different backgrounds. So we have students from the design school. They worked on all the graphic design, the logo. The software engineers that we had did the front-end development for the CMS and sending UDP data to TouchDesigner to change through JSON to change the scenes. And then we had a theater major who was a project manager, and she also worked on the AR with these UX designers, and they worked on the AR part. And what else? And then Henry, Xavier, and I did most of the TouchDesigner. And also, Wadey worked on pushing the students for the concept. And for her, it was really important that the concept had a huge,
strong.
and it was powerful. Exactly. And then, again, Xavier and Henry did all the content of the projection. So we have to give them a kudos for their support on this project.
Yeah, it's a great way to get to exposed to the expertise of other students and teachers, of course. But
And then, so how do you document something like this? Is there some sort of repository? Is there, because it's such an amazing experience and live interactive piece. I guess you photograph it and videotape it and document it that way.
So actually, we did get a video crew from ASU, but we haven't received the footage. Actually, those amazing photos are from Wadey's amazing iPhone.
I feel
amazing.
Wadey is being mentioned so much. Should we already? Should we just, before we forget it at the end, should we just mention that she's going to be presenting a piece at the planetarium in Berlin?
We should.
Okay.
Yeah,
So
we're if you don't know, we're having a TouchDesigner Berlin event April 25th and 26th, and it's going to be 12 speakers, and there'll be a night at the Zeiss Planetarium in Berlin, and she's going to be one of the Dome presenters, so we're pretty excited.
Yeah, her content is beautiful.
It's really beautiful.
So we did look at the team here. Those are basically, is that the faculty or students that are listed here in the page?
So mediated experiences is the research lab that I just started here at the Mix Center. So we have 5 different lines of research. One is mediated membranes, and it's everything that has to do with architectural, large architectural communication, I call it. Then we have mediated DX, anything that has to do with data explorations, because I teach data exploration, we work, and that's what actually Marcus has been helping us today, and we'll review later. And then we have mediated XR, everything that has to do with extended realities. I include immersive experiences in that realm. Then mediated ethics, as we talked about my dissertation, and mediated AI, because everything at the end that we end up working with, we're using AI tools. And as part of this research lab, I have these 6 amazing grad students that have joined and have been collaborating in all the projects that you see in the website. And they have different backgrounds. Some of them are, Unity developers. Some of them are working with physical computing. Others are TouchDesigner, and also the visual communication students. And they've been helping start up this whole website and everything that we've been doing so far. So I'm very excited to be working with them.
Nice.
Super nice.
Yeah, that's lucky when you're in such an environment as a student. And as a teacher, I guess, as well.
Yeah. And with all the...
and we just got granted a space as well, and it's like a dark space that you can rig, but it's just really cool. And we're building an XR stage prototype there, so we can run some tests ourselves, and we have a space where we can create and throw things and leave prototyping and experiment. So that's very fun. And I got some furniture for the students right now so that they can hang out there as well. And I should be doing this from that space, actually. I didn't think about that.
It's okay. You've got TouchDesigner open behind you on your screen, so we're all good. We're all good. So we have time. I think we can jump into spray cocktail party, because I think we really need to.
Okay, so
if we do 5 minutes of this, because I think Michelle is eager to have as much time as possible. We'll end here before we go into the more devy part of this programming.
Okay, I'll run fast through this project, but this project is a project also at the artist scale and individual scale, and during the pandemic, I collaborated with one of my long-term friends and amazing artist, Olga de Dios, and she's like an artist that works with sprays and spray can, and she developed this special technique working with latex that she is able to layer different spray, what would I say, color layers onto her paintings, and she works with these characters. She's known for them, and she was having a solo exhibition in a gallery called Swinton in Spain, in Madrid, and this was still during the pandemic. We still had restriction to bring in too many people into the same space, so we couldn't have we were going to do a performance for the opening, but we couldn't have tons of people come in. So what we did is that we did multiple performances, one after the other one. And what we did is that we created a sound piece. I also make music with my music partner, Ivan. We're called Ivana Bites together. We used to make music when we were in the 2000s, and we were called Ivana, but now since we do electronic music, we're Ivana Bites.
Amazing.
And anyways, so we created a song with the artist, and it starts, we use the sounds of the spray cans to create this piece, and the idea was to bring her paintings alive with projections. So when the music starts, these paintings start getting some projections, and then their character starts to move and to wiggle, and they come out of the paintings into the walls. And depending on, so we used TD Ableton for this synchronization. So we have different synthesizers and MIDI controllers and guitar elements that are totally synchronized with each different big important character of each one of those paintings that you see. And if I started the guitar, one animation would come out. So we'll see later, I think, in the video. This is all the beginning of the performance where we're shaking the cans, and it's all in the dark.
Do you want us to fast forward a bit?
Yeah, I think so, because it's 10 minutes long.
Let's see how well that works. Sorry, I haven't tried that actually.
Oh.
Does it work? No, we're stuck with 10 minutes of video.
Okay.
Oh, really?
Sorry.
Okay, well,
Can we show, in the meantime, some images? Or we have to wait?
Do I have images for this one? Sorry.
hang on, I'll find...
Is it on your website? Yeah, it's on your website.
Yeah.
Okay.
Yeah.
Let me just go there. 1 second. Website, good. And here is the project, I believe.
Yeah.
There we go.
Yeah. So we can see you can see the painting and how the actual painting, and then animate in different ways. So if the bass will start, those heads come out. When you watch the video later, you can hear with the bass, and they're coming out. And you see that big red one. He comes out when the guitar does the first strum, and everything is timed to beats, frequencies, and different instruments live. And yeah, people loved it, and they were dancing, and it was just really cool to give life to her work through the music and as a concept. Oh, and then the gallery made a cassette release and send it to it's a limited edition. So we have, you see, all the artwork is also from the artist.
Wow.
And it
You
has
had
all
old
the
school
lyrics.
cassette?
Oh, I love it.
Yeah. And it has all the
Wow.
lyrics,
Analog?
and then and that's the three of us.
They're coming back.
So yeah, we got they produced a cassette with everything. So it's in our piece itself, the cassette as well.
That's great.
Collectors.
But were the paintings painted in such a way that it was known that projections were going to be added to it?
No. We came up with this later. But also Olga's paintings glow in the dark if you have a flashlight. So that's why we started in the dark, and I started projecting like a blue light, simulating what everybody was doing with their flashlights. And then with the music starts, the elements start coming out, and then we had particle systems, and you can, if anybody's interested, you can watch the full video.
Yeah, I put it in the chat, so it's there's a 10-minute link, 10-minute video in chat. I recommend everybody watch it.
But it's just pretty amazing what you can do with TouchDesigner and music as well. It just was, it was beautiful. And being a performer as part of that was also great.
nice. Yeah.
That's such a range of projects, Anna. Right?
Yeah.
You got the really serious stuff, and then you got the really seriously crazy stuff. And congratulations so far on that.
Yeah, and then using it for artistic practices.
Yeah. So what's other than the academic stuff? Like, is there other projects that you're really excited about right now, or are we going to be sort of talking about that next?
So right now I'm really focusing on research work. The project that Marcus is helping us with this. We're doing a collaboration with the National Cardiac Research Center of Spain, and they're immunologists. They're looking at white cell data. So we can't really share the actual data with you that we're working on, but thanks to that data visualization class that I've been teaching in TouchDesigner for urban environments, the students had the skills to help me out with this project, and we're visualizing all these data sets that these scientists are giving us. And this is a pretty cool project that we're collaborating for their publication in scientific journals. So I think that's also a really cool thing. How can science and the art that we do and all these tools can work together? And it's just so cool how they're super excited. We have this whole data set, and the idea of them being able to navigate through it and maybe put on a VR set and explore it is just unthinkable.
Yeah, art is sort of a whole other avenue of accessing difficult to iterate scientific things, right? I mean,
yes. And the other large project I'm working is what I was telling you. I'm very interested in how large-scale architecture and media can communicate with the environment, the city, the inhabitants, working with real-time data. So I'm looking right now for funding because, of course, I need to fund the lab and fund the students. So working on that in parallel as well as these projects.
We'll definitely keep us posted, and we'll keep track of what's going on. It's exciting.
Amazing.
Yeah, just for everybody, you have all the socials on the top left corner here to check out the wealth of project that you have worked on, Anna. That's a very nice catalog. Very nice catalog. On your website there. And also you can follow with your current work at mediated.xa on the website there as well. And this is what we're showing here in the bottom left, this project that you were referencing, this white cells project, data visualization to it. So it's nice that all these updates are coming also to the website. Like, it's great to follow your work via that. Yeah.
I would like to go to Arizona and see it in person.
Please do. Can't wait for you guys to
maybe
come.
we'll take that opportunity to switch over to the task at hand to look a little bit at point clouds.
Let's do that.
Because so the data set that you have is something that we cannot share here publicly, but looking at it, it became apparent that, and it's a funny coincidence, so to speak. Your data set has position of those cells and the velocity with which they move. And the data set that we will be looking at is a little bit a different scale, and some of you might know this from a YouTube tutorial, but it's basically a star catalog. And the star catalog has a position of the stars relative to the sun, and a velocity which I believe is parsecs per year that those stars move relative to everything else. And that makes it a good stand-in. It doesn't look as like, if you see your data set, it's so nice, like the shapes that it creates, but anyway.
Stars do what the stars do.
Stars
Yes.
do what they do, yeah, exactly. And I saw in your project that you're basically using instancing for displaying all of these things. And I just wanted to point out a little bit a different approach, which would be using, instead of chop instancing, using top instancing for the whole thing, because you can actually make use of the point file in with this kind of CSV data sets that you have. So the point file in top here, and I just gotta grab this star database here, all the stars, and it's loading. Approximately, this is 120,000 stars. Sorry, Michelle.
Are you going to make it bigger, Marcus?
Oh, sorry. Yeah, of course. That might help.
I think it helps. More stars for us.
You will never see me in the bottom right corner because it's going to be one of you guys. I hope that's okay.
Somebody say something.
Yeah.
Michelle, please.
So yeah, we have 120,000 stars locked here, and with the point file in, you get it as all the different layers that are in this database come in. Either you can assign them to the red, green, blue, or alpha channel, and you can always look at, just for those who haven't tried that yet, when you activate a top viewer nowadays, you can right click into it and say view as points, and you get kind of a view of the data that is in your red, green, blue channel as a 3D geometry, which coincidentally for these star catalogs looks great, even though you're not displaying any positions, but other data here, you can already play around with this. But looking at this data set, there is, what we find here is an X position, a Y position, this looks nice too, and a Z position. So we have kind of this sphere, and you can, it's a little bit misleading here. There's a lot of it is here on the edge of the universe, so to speak. And then if you zoom in, there's a whole bunch much closer. So some of these stars have like a fixed distance. I guess it's just something that's way out there.
Clamp to a maximum.
Clamp to a maximum, exactly. Now, as we see, we have way more data in this star set than channels in a top. We are limited to these 4 channels. You don't have to load in another point file in, but you can use a point file select to bring some more stuff in. And the point file select takes the point file in top as a reference. And now we can look at other data that we have here. And there is this Vx, Vy, Vz, which is your velocity that these stars move at. So you can bring this as well, and you can have as many point file ins as you like. So if we later on want to also look at some color, I can remember, what did I use here? Oh right, color index CI or something. There it is. Anyway, so all of these channels can be brought in with multiple top operators. And now, as the next step, we can render this fairly quickly. And I'm going to do something weird here. I'm going to use a line, and that has the reason for this is that you had asked for also showing the velocity vector actually in the rendering, and the line material that we have can do this. And sorry, I have my notifications on. Let me just, actually, it should be off.
I'm asking Anna to talk, so that I think she should be on the screen and not me.
I didn't want to interrupt Marcus.
Yeah, I think if everybody else mutes, then anybody who doesn't want to be on the screen can mute. Sorry, it's the funny setup. Anyway, so we can bring in here the null as the instancing source, and this one has in the alpha channel we have an active source, and then for XYZ we can use RGB. And from the palette we're just going to use the camera viewport and then render the whole thing. Render with a camera and give this whole thing a line material where we don't want to render the lines but just some points, and just put this on, and later on vectors as well. So that's a start here. Now we can go further with this because you wanted to make the move basically, and movement would be that we add the velocity of these stars onto the position of it. So this would be a simple add in a way, like you can add those together, and will not add alpha just because you don't need to. And so this would be one step. This would be 1 year worth of movement. And now this would be nice to animate. Actually, why is this clamped like that? I don't understand that right now. Funny. What did I do wrong? Nothing so far. We'll figure it out. So to animate them, basically what you would have to do is just create a feedback loop, where top feedback loop, because you take the position, you add the velocity, and now you want to add the velocity back onto the new position here, onto the add essentially. So that feedback loop will add in a feedback here after the point file in, because this is our initial position, that's where they start off. And then we close the feedback loop here. And now you should see, well, stars don't move very fast, but you can see some flickering there. Still confused what's happening with my, why it's displaying like this.
It might be the, are you using the active parameter on the instancing?
Yeah.
Don't turn it off so that everything's visible.
Okay, there we go. Okay. I'm not sure why that didn't, what the active there had.
Yeah, it's what's in the alpha channel, so it's kind of, I don't know what you had in the alpha channel of your data at that point.
Oh, right, it picked it. Yeah, never mind. Yeah, exactly. And so now we can add a mass top here to the velocity, and we can use, like just as in chops, you can use the multiply to increase the velocity basically per frame, like how, and then that determines how quickly this is going to move. So if I set this to 100, then now we have a movement of, can't see much yet. Now you can see stuff moving there, basically.
Yeah.
So things are apparently collapsing. Oh no, we're doomed. But this is per a year per frame, so to speak, or 1,000 years currently per iteration that this feedback network is working on. So you can do the same with your with the cell data, because the cell data gives you position, gives you velocity, and this little feedback network animates the whole thing.
Wow, that's so fun. That's so crazy. I was just like manually doing vector math with my pen, you know, remembering sine and cosines. And I'm like, how do I calculate the next spot and animate through them? That is so crazy. Yeah. Thank you, Marcus.
Yeah, I mean, there's more. I would point you to this tutorial that we have online, I think it's on my channel, called Dissolving Napoleon, which kind of explains the process of, if you want to reset it, like you might not want to have a hard reset, but maybe you want to see these things as particles and give them life, so that after X amount of time they go back to their original position. So it's a continuous movement. That's explained there. It's a good introduction to working with tops and using tops as point cloud and particle operators essentially for a bit.
Great.
The last thing that I wanted to point out here before I give this over to Greg, because Greg did some more work here.
Oh,
wait,
cool.
Sorry, you wanted to actually display vectors on all the stars. So now there is the option for the line material to actually draw vectors, and so you turn that on, and this is the reason why I used a line material, a line SOP here with 2 points, because for this I need to have some proper geometry and not just some particles for this to work. And the line material vector page, you can assign any attribute. You can use any attribute of the geometry to draw the vectors. And it also has the instance custom attribute. So we can use this. And on the instance page, on the last instance page, you have custom attribute ops.
Yeah.
And this can be your velocity. So if I drag my velocity into here, now I have this as a custom attribute, RGB, and that should be the first one. And let me just check what I had on scale here. Had a round and arrow. Just gonna copy a couple settings that I had here to try to make them show up. And on caps, you kind of can control how your arrow should look like. That's the so you can set an arrow width here and yeah, arrow height if you want. Things like that are controllable there. And now I should really try to get. Okay, I'm just gonna, because I messed up my camera, I'm just gonna show this here in the geo viewer. So now you have these all these vectors drawing.
Okay.
Looks a little bit weird, but that's how it is. Ah, shit. Sorry. This problem happens, and I had a quick solution.
Did you get stuck in where?
Can we have that discussion, please, again? Because this is going to be painful. I have to
So
use
Marcus,
pane
to
class.
make this longer, you can use the length multiplier.
Sure, but first I have to. Is it UI.pane?
But yeah,
Dot,
or
Mark-
Peter.
dot zoom
Mark-
equals 1? Yes, thank you. Can we just have this as a button, please? I don't care.
What do you want it to do?
If you go into an active viewer and the active viewer is like me, you start zooming into it, like this, for example, and then you start interacting with the viewer. You're now stuck in the viewer. You cannot out. And the only way to get out is UI.panes 0.zoom equals 1. Anyway.
Everybody will know that
Well,
one,
that's a
right?
feature.
Yeah. So
Okay, you're right.
I'm gonna leave the niceties basically because I don't want to take up too much more time. I just wanted to also point you to the coloring of the whole thing, because in the file that you have, the colors are described as a color index. And then you use that as a lookup into a color table that you created. And I'm gonna kind of do that here just with some random colors to show the general idea that I would, or the general approach I would take here. And red, sure, great. Black is not good with stars, they disappear.
Marcus, quick question from the chat. Is that star data set available somewhere?
Yes, so the star data set is available, and I thought I had that written down somewhere. 1 second.
We'll find it eventually.
Yeah, I'll just finish this thought and then I'll continue this. So the channel that I might use here has -0.4 to 5.46 as an index, and I'm just going to use a mask top. This is nothing you have to do, but to come closer to what your data is looking like. So I'm going to use my range in the mask top here to rearrange the values from -0.4 to 5.46 to 0 to 10, for example. And then round it to make it an integer. And now I have, in the red channel here, I have now a range from 0 to 10, which is fairly similar to your data set. And now I can use this as an index into a lookup top, where the first is the index, the second is my lookup. And just as in chops, I can say my indexes are 0 to 10, and for my index channel this should just be red itself. And now I have a color channel here for that is determined by the index number from your data set, which you can just add to, well, as you did basically, onto your instancing here.
What are you thinking, Anna?
That this is great.
And yeah, and then you can.
I'm very excited.
You can become
It's
pretty
funny
creative
how
there, just adding more. Like if you wanna have a creative mode there to add different movements that are not necessarily true to stuff, then yeah.
That's and the number of nodes that our file has compared to the number of nodes that yours have, it already speaks for itself, you know.
And the other thing is, considering that these are just textures, those textures are pretty small. Like this is 120,000 data points, but you're only dealing with 350 by 350 pixels.
Yes.
So it's really performant for what you can do there. Yeah. And I think, Greg, with this, I would just give it to you. Now, Greg's file is going to look quite different from this, but that's perfectly fine.
Thank you so much for working on this, Marcus. This is so cool. I'm so excited. You're going to share this with me, right?
Yes, I'll send you the... we'll send you 3 different files because we're working on 3 different files for this.
Wow.
Right.
File number 1.
Thank you.
So I started with something that Marcus gave me yesterday, which is a bit farther than what he showed. So this one has, well, the properly colored stars that you had set up before, Marcus, and I added a bunch of parameters, including the reset of the feedback, turning on drawing of vectors and not. But the main thing was I wanted to figure out, like, what this is kind of a cloud of stars, but you really don't know anything about their dimensions. So I started to put in something with more dimensional. So I had a flag called clamp the box, which basically clamped all the points to the size of a box. So the clamp size 465 means 465 parsecs, which is, I don't know how big that is. It's pretty big. So I just wanted to focus on, and I was able to, clamp it down like this. And then I wanted to focus on some, stars that are kind of in the middle. So I also added a flag, which means dark, which is darken outside box. So this is this is now darken outside sphere. So again, focusing on a set of stars in the middle. So the first one's done. Okay, let me just go back to the box only. That's simply done with a. I took Marcus's feedback data. Here are all the spheres and stuff like that. But then I just passed it to a clamp, a limit top, and just clamped values to half the size of the the size of the clamp size, the parsec number of parsecs of the size. So it's a pretty simple thing to switch on and off. And I did a trick here that not many people know about, is this clamp to box thing. You notice that nothing changes here, but what changes is actually on the common page. There's something called passes, which is kind of like a bypass parameter. So basically, this is just turning on and off the limit. So if it's 0, if passes is 0, then it just passes the data through, like as if you hit the bypass toggle here, or the bypass flag. So this only exists in tops, and it really should be in chops as well, but it's a way of procedurally bypassing things without writing scripts.
Mm-hmm.
Okay, so that's that takes care of the clamping of the box, the stars to the box in terms of their position. I also pulled from the palette this thing called point field, which is a way of getting different kinds of diminishing of basically point field outputs a weight. You take for instance, I'm taking the XYZ position, and alpha is at 1, and what this thing does is output an alpha channel that has a weight value in it, which is between 0 and 1. Well, actually, I scale it. There's a parameter here to scale it so that you can have a minimum weight of 0.19 and maximum weight of 1. So what I'm going to use this weight for is to modify the color that is being passed to the line material before the colors are output. So, for instance, right now the color is going straight through. All the stars have the original color that Marcus has set up. So if we do darken outside box, it turns on again. I'm using the same trick with the common pages passes to turn on and off the number of passes. So if it's on, then the alpha channel. The weight goes. The weight is just multiplied. Like the colors are in this case is just I'm using the weight value to when brought from the alpha channel to the RGB channel, I multiply the colors coming in, and so some of these stars are going to get darker than others, and that's why some of these stars here are darker than if you turn off darken outside. Fine. So those are the darkened colors that are being sent to the line material, well, basically to the instancing. So all the points outside a sphere here are 0. Well, not 0. They're 0.19 in multiplied, and so there's other things you can do with point fields from the palette. You can put noise inside a box. Well, I sort it relative to a point, relative to a plane, so you can clamp things and shift things. Look at things relative to a clamp plane. You can soften the edge a bit using this fade out thing, so you can soften the edge of it, and you can do it relative to a box, which is sort of similar to the clamping of the limit. But anyways, what we want is relative to a point, and so from here, now I can start inspecting things. So on the parameters, let's see some motion. Okay, so these are all the vectors of the star motion. So great. Well, actually, before we move in, let's reduce the vector length so it's not so overwhelming, and make them a little bit wider, and just let them rip. So this is watching the star motion deep inside the star cluster. Now, of course, it's going pretty fast, and the representation down here, 260, that's 260 years per second on the timeline. I think this might be multiplied by some larger number, because this is a pretty fast motion, but because this whole thing is a cluster, all these points, like we just, all these points are going to end up flying outside the box. Actually, let's just not clamp to, not darken outside the box. Let's see, and not clamp them. So off the things go. So if we pull back a bit and reset, here they go flying out. What's that, Marcus?
Did you just change, because in my original file it's years per frame.
And I changed it to years per second because somebody might be running on this on a 240 frame per second simulation. Simulation. So I work in seconds. So we have this battle at derivative.
Just
people
for me,
work in frame versus those that work per second. What's that?
For me, it's not that fast, so there might be an error in that calculation.
Oh, but no, it's fast. It's fast if you get closer. But anyways, but also change the range of the slider here to be more conducive to demoing this. So, so we can start the simulation again. And because this data set is just a limited data set of stars, everything will thin out because everything's going to go into deep space anyways. So yeah, I changed the range of your parameters a lot. And the other thing too is you shouldn't actually be, the multiplier shouldn't be the frame rate of the timeline, is how many steps you move forward every time that how many seconds you move forward every time you render the image, or that you cook the image. Because if you're running it, I'm running at 16 frames per second. If I was running at 60 frames per second, this thing would actually run faster. So it's not really good unless you use there's a Python member that tells you how many frames the whole simulation or the whole process step forward is. 1 divided by frames per second here. Anyhow, that's the deal. Let's see, what else did I want to say about this? Yeah, you got to, right, so just when preset positions, back out again, and so on. So I think that's about it for this.
Over to Michelle. Anna.
Can I ask a couple questions here?
Yeah.
Before we change. Yeah. And thanks so much, Greg, for working on this, and it looks great. And just one question: we have different clusters in our data set, and we've created 3D models and surfaces of each cluster. Manually, we have to do it, retopoing. And I'm wondering if the clamping, like what you were doing with the box, if it could be done with a 3D model, a surface that we bring in, because that would be amazing.
Yeah, well, clamping. Well, if everything's in texture land, is the surfaces are as polygons, or are they as?
I think they're meshes. From
meshes.
Blender.
Yeah, because the point cloud workflow only works well with separate points versus polys. Although you can take all the meshes and apply the same operations with the limits. If you get your points into tops, you can get clamp things there, and then output back to polys, back to meshes. So I guess you could do it. You could do it as well.
Okay.
I would like to point out one other thing before I forget it. The feedback loop is a little bit, you have to add, and this will be in the final file, you have to add a little script like on start reset on the feedback, because the point file takes a little bit to load while the feedback is already running, and that would totally destroy your data set. So there is a little execute that up there that resets it after 100 milliseconds or something like that. Oh, is that right? Here? Okay, reset pulse after after 100 milliseconds, you reset pulse there to restart the feedback when you reload the TouchDesigner process, right? Correct. Yeah. Mm-hmm. Yeah. Okay. What other things did I do here? Nothing there. I think that's about it. Yeah. Okay. That's about it. So, anyway, but I was basically using Mark as a starting point. And like, I'm a big fan of using this mode of RGBA in separate channels, because you can see the lower and upper limits of what your data set is. Okay. This is amazing. Thank you. Can't wait to share with you what we do with all this information. Yeah. Go vectorize. Right. So I guess we'll switch over to Michelle, if that's okay.
So Anna, why are you looking into WebRTC?
Well, I was looking. So one of the ideas, since, for example, what we were looking at the building of the Mix Center and the jumbo screen. I work with the students on creating these real-time data visualizations of the city. And the idea is to be displaying that information about the city on those large screens. And we would like to have a web portal for like a online presence at the same time as you have a physical presence, so people can access it and interact with it from outside and get more information, not necessarily. So the idea was to have, we can have a server that's actually running these visuals on these large screens, but in the physical screens, but also have the servers running on a web browser. And the idea, and to be able to interact with it. So we're looking at WebRTC, and since if we want to have multiple users to be able to interact with these real-time scenes that are being streamed, and the information go back to TouchDesigner and so on. So that was one of the main purposes.
Makes sense. Good idea.
Okay. Is my audio okay?
Yeah, to me.
I see myself, so I guess it's working. Okay, cool. So WebRTC, it's a bit of a difficult topic to get into at first because there is a lot of documentation on the internet about WebRTC, but you don't necessarily know where to start. And I did put together a few links that are also part of our official documentation. And I think a good starting point for users is the Mozilla documentation, which covers the WebRTC API. So this documentation is not going to cover TouchDesigner, but WebRTC, being a web technology, is a little bit of JavaScript, and that's where things are actually starting with WebRTC. So yeah, going to the Mozilla docs to get started is a very good starting point with a lot of code snippets, demo, and all that. So if anyone wants to get started, look into it. Another good resource is also the Media Capture and Streams API for the web part. They really work together. So the Media Capture and Streams API is really that API for web browsers that will tell to the web browser what are the device that are available, like your webcam, for example, and also what are your audio inputs that are available. So this is all part of the Media Captures and Streams API. And WebRTC connections, when they are made, they show up as streams. So that's why it really goes together, hands in hand. You can find it, the link here as well on the WebRTC API starting page. On our end, the documentation, we have a landing page, very easy, docs.derivative.ca/WebRTC, and we can find all the information on this page about WebRTC in the TouchDesigner context, including what are the operators that are in TouchDesigner and that are compatible with WebRTC, such as the WebRTC DAT, which is really kind of that pillars at the base of anything WebRTC in TouchDesigner, and also all of our components that we ship in the palette with WebRTC support. So with that being said, one of the big points when you want to get into the WebRTC world is how you're going to connect computers together. Okay, so a computer sending a stream from TouchDesigner to another computer, or a computer sending a stream from TouchDesigner to a website, for example. Okay, how do you connect those points together? And in WebRTC, this is what we call the signaling process. And the signaling is part of any handshake, so the way to make the WebRTC connection happen. And this can be done by pretty much any protocol. it's not spec'd. It's just there is a whole philosophy that says, okay, the signaling process, you can set it up in a certain way, but you can have it happen with WebSocket or a REST API or some other protocols that I use would be MQTT or anything, pretty much. So in our tools internally, in TouchDesigner, the whole signaling process is done through WebSocket, and we are shipping the palette with a signaling server and a signaling client. So that's really where we are starting. Okay, so I will set up a signaling server in the current process, and I just drag and drop it from the palette, and I will briefly go over all the parameters and the configuration. They are really in details explained in the wiki. So here, what we have a port that we set up, so that's on which port other machines are gonna try to connect with the server. Okay, and then we can set it up just like a web server with TLS and the certificates. We'll see later that it's needed for when we want to communicate with web browsers, because there are very strict policies when it comes to HTTPS versus HTTP and all that. I will go in the details for this a bit later. And then we have a few features that are coming with all the signaling components in TouchDesigner and the WebRTC components that are JSON schema. So JSON schema is in JSON for web APIs, it's a way to describe what are the messages that you expect, okay, through your web API. And when you receive a message, you can compare it against a schema and say, okay, this message I just received is valid. There is all the information that is needed in that message. So this is here on the web server, on the signaling server, for anyone that wants to implement the signaling API using any other environment. It doesn't need to be TouchDesigner. It could be some JavaScript client or some other Python client outside of the TouchDesigner context. They can test the messages against this schema, okay, to confirm all those messages are valid. So you can turn them on and off here. You can also cache them, because right now, if you don't cache it, it goes get the schema files on GitHub. So there's a bit of latency. But once it's done, it downloaded the file once, it gets better. And you have details such as what is the signaling API version right now in TouchDesigner, and so on. Additionally, you also have a logger page on this component, and this logger, what it does is when you enable it, it just tells you everything that is going through the server, so that you know if some messages are badly formatted and the server don't quite understand the messages it's receiving. You can enable all that, sending this to files on disk, or send it to the text port, like you're familiar with, opening the text port and seeing all your messages being printed in the text port. So this is on this page. It's disabled by default because there is a bit of a performance cost. Every time you receive a message logging what you receive, if you have multiple people connected on the server, it can become a bit of a bottleneck. So it's disabled by default, and you would mostly use it during your development process. So let's get a simple server running like this. So right now we have the server running, and there are no clients right now. We see that the list here is empty. So I will just drag and drop a signaling client, okay, here, and nothing happened because the client is turned off. So we can see on the client, we can specify the host. So right now I have the client next to the server. It's going to be a local host on the same port. And I turn active on, and we see now I have the client here on the server. If I add another client like this, we see that right away I have another client showing on the server. I can delete it. The client is gone. So it's really the server reacting and saying, okay, here are all the clients I see and I know of. And because those clients are all exchanging through the same server, the server can signal and tell from a client A that doesn't know about a client B, here's how you connect to the client B, because they all connect to the same server. Does it make sense? Oh. So now that we have those two things set up, what we want is we want to have a WebRTC session going on. So I'm going to drag the WebRTC component here in the palette. And this WebRTC component is a bit of a component that does it all, where it's set up kind of a Google Meet in TouchDesigner or Microsoft Teams or anything through TouchDesigner. So I will open another process here of TouchDesigner where we can imagine this other process that I open being another client on my local network or somewhere in the world. Okay? Just for the sake of the demo, I will start with that simple example. And we don't need to drag and drop a server because we already have a server running on the machine. So I'm just going to drag and drop the client. Okay? I'm going to turn it on. And we see here, I have the other client that showed up. So now my client here already knows who is the other client connected to the server. Okay? So there is the ID, and there is the address and the port it can talk to this client through. So now I'm going to drag and drop another WebRTC comp. And I will just go back briefly in the other file, because I didn't quite set up the WebRTC comp here. And we see here, the WebRTC comp is expecting a signaling client. So all the tools here that are WebRTC in the palette, they are built in a similar fashion. They are all wrapped around the signaling client. So what it means is that here's the WebRTC comp. When I'm going to assign the signaling client to it, it will know, okay, this WebRTC comp is using this signaling client instance with those specific settings. And on top of this, the WebRTC comp, it has some messages that it wants to know about. So there is in the code here, in the Python code going on behind the scene, there is an extension that tells to the signaling client, hey, when you receive those messages that are typed with what we call a signaling type, I want to know about those messages. I want you to forward those messages to me, because as a generic signaling client, you don't know what to do about those messages. And I am the WebRTC comp. I know how to ingest those messages, or to process them, and what to do with them. Okay? So here, I have my signaling client active. We're good to go. We are connected to the server. And we can see here that little toggle forward to subscribers. It will likely disappear in the future, but I'm going to turn it on here. And when I'm setting up the signaling client on my WebRTC comp, the WebRTC comp is now a subscriber of the signaling client. That's why there's a toggle here. So what happened is that now on my WebRTC interface here of this WebRTC comp, I can see that I have the client appearing here that I can connect to, okay, with that little call icon. And I know I will go in the other process because I still need to set up properly the WebRTC component of the other process so that it can know that it is receiving messages through the signaling client. So I will just turn the subscribers on here, set up the signaling client. And we can see now in that process, I also have my WebRTC comp with a client ID showing up. So this is a client I can call. Okay. So now if I'm going back here to my main process with the server, we're going to start a call. And you see, I have a call that started. And now I have my WebRTC in the first process connected to the WebRTC comp of the other process. Okay, so we can imagine that those are really on different machines on the local network, or that they are on totally different locations in the world. Okay, you would just have to set up your router. For you have to deal with security, port forwarding, and all those kind of stuff that usually ITs or network administrators take care of. But it can be done. The tools are here for this. So you could just connect. I could connect myself to Toronto, to where Marcus is right now, without knowing the IP of Marcus at all. As long as we both know how to communicate to the server, that's all we need. Okay? And right now, because the call is ongoing, the server can be done. It can be killed. The call is not going to stop. Okay? Because what happens is, that's the magic of WebRTC. Once two people are connected, they are connected peer-to-peer. They don't go to the server anymore. Now we have A and B connected together. So in this interface here of the WebRTC comp, you have here a button called Manage Tracks. And in WebRTC, you have what we call tracks, and also data channels. So you could have over one WebRTC stream multiple tracks that are multiple video tracks, multiple audio tracks. They can all go through the same stream and being sent at the same time. And on the receiving end, you can filter out and say, okay, here are the tracks that I want to listen to, or here are the tracks that I actually want to ingest and show on screen, and so on. And the data channels are a mean to exchange messages between peers, so between A and B, that are not necessarily audio or video tracks. Okay, so we have one data channel here that is mouse. Okay, and what it does is that behind the scene it just takes the multi-touch in DAT input, and it sends the rows of the multi-touch in DAT, it sends it over the data channel. Okay, and maybe it's going to be a bit difficult to see on the stream, but if I click here, and maybe I broke it some way, but the data channel of the mouse is being sent from A to B. Okay, so it should be seen here. Right now it's not quite working, I think.
We can see
for
some
red reason.
dots. Is that what that's different?
So yeah, the red dots are not quite what I was after, but yeah, I'm not sure what went on. I will likely debug this small last minute bug. So that's it for the WebRTC comp. And what we will look into next is how to send a panel from TouchDesigner anywhere through WebRTC. Okay, so I have another server running on my network right now, and I've set it up a few hours ago before the call. I don't remember exactly how it's set up, but I know it's here waiting to send me something. Okay, so I will just close one of those processes that I have running, and here we're gonna just delete everything, and we will drag and drop a signaling client, okay, and a WebRTC panel receiver, okay. So the WebRTC panel receiver is here just to receive any video stream from a WebRTC panel and send back any interactions that you have on the client. Okay, so here I'm gonna turn on my signaling client, and we see it cannot find anything, and it's just because I'm still set up to localhost, and I know the IP address of the server. Okay, I don't know where is that client, that other client I want to communicate with. I just know what is the IP address of the server. And here I have it. So I typed 192.168.0.102, which is the IP of the server. And I see on my client that I have another client that just showed up. I'm going to toggle forward to subscribers. And on this WebRTC panel receiver, I'm going to drag and drop my signaling client and turn it on. And I see here that I have the other client showing up in that drop-down list. And this is the client I want to connect to. Okay, I want to receive a panel from this other client. So I just connected, and here we have it. So what's happening is that if you see the size changing, is that WebRTC is buffering at the beginning when you first start the call. It's going to take a little while to figure out what is the optimal setup for your pure connection. So what is the optimal setup and the bandwidth that A and B can work with, okay? And here on my other machine on the network, what I have going on is actually the well-known Particles GPU from the palette. Okay, it's running on the other machine, and you can see that I can interact with it. So what's happening is that anything happening in my panel here locally, so my mouse clicks, and even my keyboard events are being sent out to the other machine. Okay, so here if I middle mouse click, I can zoom in. If I right click, I can pan, and all that is supported right now. Okay, any questions so far?
Interesting. So I don't know why it's reminded me to the the notch blocks when they go into TouchDesigner, that if you set up some parameters, you can manipulate them from somewhere else, and they're actually from a different platform. And how would we do this from? So if we could display this from a web browser at some point. And be able to.
That's gonna be the next part. Should we go with that web browser? Okay, let's go with that. So, all right, I'm just gonna kill this connection here for now. And I will also kill this client, and we will just set up a new server here so that I work locally for now, not to overcomplicate things. And I will turn on my server, and I will turn on TLS for so that I can add a certificate to the server, because it's important since we're gonna go browser side. In the browser, Chrome doesn't like to share video or audio when it's not protected. Okay, so it needs to be over secure connections. So my server is running here. I will just go here, and I will set up a local certificate. Okay, so to set up my local certificate, what I'm using is that I'm using that little tool here called Make Cert, and it's to generate SSL certificates in development environments. They are self-signed, so it's really handy when you develop. And to set that up on Windows, you use Chocolatey, which is a Windows package manager. And in Chocolatey, you can just type something like Choco install Make Cert, and it will install it for you. Okay. So I will just show it here. Make Cert is now in my terminal, and that's how you generate your certificates. It's all explained step by step in this GitHub repository on github.com/touchdesigner WebRTC remote panel web demo. And all the issues that you can encounter that are very common issues in development environments when it comes to SSL and certificates, they're all explained here. Okay, so if you want to get back to it, it's a good place. What we will do is we will jump into my project folder, which is, I will show it briefly on screen here, WebRTC sender.to, and we will open a terminal window. And this is where we are going to generate our certificates to work with. Okay? Just kill this one for now. Here is WebRTC sender.to. It's an empty file for now. Here's my terminal. So in the GitHub repository, what we want is make cert install, and it's gonna install what they call a root a certificate authority, if I remember correctly, which is just basically someone on your computer that's gonna issue certificates and say, oh, those certificates are valid. So here it's set up, and the other comments we can just copy paste from GitHub is here. And what it will do is it will generate a certificate file and a key, which are valid for my host right now, which is localhost. Okay. All right, and it's done. And if I go look into my folder, I now have two files, a certificate and a key that just showed up. So we're good to go in a development environment, and we'll just drag and drop the server again here, turn on TLS, and select the key, and select the certificate. And on the port, we're going to go on a secure port, which is usually 443, and turn on the server. Okay? So we have the server turned on right now. What we need a signaling client to talk to the other client, and the other client will be the web page, right? So I'm going to drag and drop a signaling client, say I want to work on port 443 of localhost. I'm turning on forward to subscribers because we're going to have some subscribers. And we want to drag and drop the WebRTC panel because this is the component that's going to share a panel. Okay? Yeah. So on the WebRTC panel, we're going to drag and drop the signaling client. So now my WebRTC panel knows how to signal itself to some other WebRTC peer somewhere on the internet. Okay, and we're gonna share a panel, and the panel we are going to share will actually be, I think, some star system we saw earlier. So let me just load that. Here, I think that looks like it, right? So we're just going to copy paste this tux into this file. Okay, and by copy pasting this, I broke something. And if I'm correct, it's just a point file not pointing to the proper location. And here it is. Okay, so let's restart the simulation. And now we have the simulation going on with our little stars moving around. Okay, so this is the panel here that we want to share over a WebRTC connection, and we want interactivity to be relayed to, right? So this panel, I'm gonna drag and drop it on the panel parameter of the WebRTC panel here, okay? And the WebRTC panel, I'm gonna turn its active parameter on. And now we will go to the internet. Okay. So on the WebRTC demo repository on GitHub, there is also a precompiled version of this repository running on the internet right now. Okay. So the way to access it is just to go to this URL here, which is touchdesigner.github.io/WebRTC remote panel web demo. Okay, so now I have here the web demo in my web page, which is gonna be the host and receive whatever I'm sending from TouchDesigner. Okay, and we went through that whole process of generating certificates because, as you can see, this is running on github.io. It is with a secure connection on a protected domain with a valid certificate. So we need all our process to be secure along the way. Okay. So it was pre-filled with 127.0.0.1 on a secure WebSocket. This is the address of the WebSocket server we want to communicate to, which is just here in TouchDesigner, right? Or signaling server. And because it was pre-filled and all the parameters are valid, it connected right away by itself. It wouldn't have worked. Those buttons would be in different colors. They would be the other way around. Okay. So connected to server, yes. And we see here already that a client is available in the list, right? So let's just hit start and hope that everything is going through as expected. Oh, and it is. So we have this, the star system right now is being sent from TouchDesigner to the web page. The connection, the initial connection happened through the signaling server. And right now, if I kill the signaling server, my connection would still be ongoing because it's connected peer-to-peer from A to B. And we can also interact with everything.
Wow. That is amazing. This is so exciting.
So I can
Well,
just...
Michelle, thank you so much.
Anna's happy.
Yeah, very happy.
Amazing.
But you can even have clients like interact with something remotely, you know, like you can show progress.
So yeah, you can you could you know, have all this set up so that you can share interactive project with a client that is out of the country right now, or you know, the tech is used I know, for example, by real estate agencies. You know, when they do virtual visits of homes, they usually use WebRTC to do those visits. And you have a rendering server, you know, running in the cloud and sending that image to the client on an iPad or whatever. So this is WebRTC behind the scene, usually for those kind of experience.
So you have a this connection is using 3 data channels as well, like you showed before. The video and data, at least the mouse data. You have that set up for this particular demo.
Right now, for this specific demo, we have a video track, okay, and we have 2 data channels. One for all that has to do with mouse events from the browser. So it's using the API from the browser for, you know, all on-click events and all that. It's relaying everything to TouchDesigner through a data channel. And we have another data channel that is open to relay all the keyboard events. So if I press enter, it's gonna relay that the enter key was pressed to TouchDesigner. It's not ingested right now on the receiving end, but if we still have time, I can show how to either use this data channel or even add another data channel.
You've got 5 minutes.
5 minutes is gonna be a bit tricky.
And I have a really fast question. What I asked you the other day, so what would happen if you have multiple users on the web browser and different different?
Right now, this sample is really one-to-one. Okay, so you would have to dig in the code to scale it, but another version that is already scaling is what we showed earlier, the WebRTC component, the Google Meet style of component, where you can have many WebRTC connections going on at the same time, okay? Between multiple clients. So if you put those codes together, if you look into the code, you can figure out it's using a replicator, or it's every time there is a new connection, it's just replicating the setup, you know, so that it can accommodate. So this is the way it's set up right now. Now, does it scale well? Internally in TouchDesigner, we are not supporting hardware encoding right now. It is being worked on. It is gonna it will be a feature at some point. It is being worked on. So because we don't have hardware encoding right now, is because behind the scene it's using the encoder of WebRTC, the official library encoder, and they don't give an hardware encoder with that library. And because we don't have hardware encoding, at some point, if you have many clients, it's gonna start to be, you know, a bit heavy on your CPU.
Because as it is, each time, for example, each time a new client connects, you will replicate the real-time 3D scene, right? And TouchDesigner is just having another scene, right?
That depends. You could all share the same 3D scene and interact all at the same time over the same 3D scene. So you would just share, you know, one 3D scene for everyone to interact with. However, the WebRTC streamers, which is just a video stream out using the WebRTC pipeline, the streamers, that really convert your 3D scenes to a video signal to be sent over the internet. Those streamers are not hardware accelerated right now.
Okay.
So this is where there is a bit of the bottleneck. So every time you have a new client, you're gonna have a new streamer, and this can become an issue if you have too many clients. Now, even with hardware acceleration, if you start to grow everything, you might hit a bottleneck at some point. That will need to be tested depending on your bandwidth, the frame rate, and all those parameters. It's really getting deep into network management, not TouchDesigner network. Really, your network Ethernet cables and all that, because you could have just a bottleneck on your network card, for example, because you have those that have to handle.
Got it.
What people usually do for those really, really demanding setup, they have really dedicated WebRTC media servers that are really scalable. So, for example, one instance is running in the cloud somewhere, on Azure or Amazon Web Services, whatever. And when this instance is reaching its limit, they can just kick off another instance. Okay?
I see. I understand.
It's a really, really large scale setup. And there are a few names of those servers are all listed on a wiki on docs.derivative.ca/WebRTC with a few way forwards if you really need to support 100, 200 clients, for example. So having a setup like this with a dedicated server, it would really allow you to optimize on the TouchDesigner end so that you have that one 3D scene being sent to the server, and it's then the servers taking care of dispatching that video stream to all the other clients. And also this server is receiving data channels from the client, and it's taking care of sending all the data channels to TouchDesigner. That could be, one setup, for example. And with this kind of setup, you can really connect everything together at the end of the day.
Awesome.
I think we went through everything.
Yeah. Marcus, I just remembered we have an announcement to make before we wrap up.
Absolutely. I mean, if we want to wrap up, I thought I'd bring us all into the same... We have 5 minutes. Okay. I just thought because we're not focused so much on the screen anymore, I thought we'll put us all on screen.
Yeah,
so
that's much better.
See more people. Anyway, this is. I mean, it's a lot to digest there, but it's great to have this now on video, Michelle.
Yeah, really.
Thanks, Michelle. That's great work by yourself and Eric Bond at Derivative, who worked on the C++ part of it. So Anna, I kind of had a question for you. What next?
Oof, there's so many things. Well, there's I have there's a possibility of a project in Madrid for the Museum of Video Games. I don't know if that's gonna happen for sure. And then I'm collaborating with another scientist from a research center in Portugal, and we're looking at fear responses and creating an experience to analyze that as well. And for me, it's like I'm full on the research lab and open to other collaborations and projects. So this is a good opportunity also to leave that door open.
That's really great. So basically, you have ASU for 6 months of the year, and then you have 6 months of the year to work on projects and develop other things. That's a very nice scenario.
Yeah, and also working with the students and in a research environment where you know, it's just like getting this opportunity to do what, you know, sometimes you're just when you have your practice, you're guided by what the clients you get and what they need, right? But being in a research environment, I can decide where I want to push those boundaries or where I think it's necessary. So it's an interesting place to be, and I'm very excited.
Yeah. Anyway, that was very exciting deep dive into Dr. Anna Herruzo's wide world.
Yes, and thank you so much, all of you. This is just so cool to have you working on this. But I mean, these are the things that were in my head in the last month, and suddenly Michelle just did that whole. It's so cool to see it on the browser. You know what? Like, oh my God, it's doable. It's there, and you know, the whole point cloud. You know, we've been working and discussing with the students all this, and I can't wait to get those files and start working on it.
Yeah, great. Marcus, I sent you a link of Bertrand's point cloud quick tutorial. I don't know if you want to put that up for a second, but that's another resource that I found really good. B2BK on YouTube, but did you see the I think I sent Bertrand. What's his last name? Debec. Who spoke at our summit.
Yeah, he's been making some really nice tutorials. There it is.
Yeah. So scrub to two-thirds of the way through. And more. Yeah, so just scrub through the whole thing.
You're muted, Greg.
You're muted.
Yeah, he scrubs through the whole thing. He's doing a lot more crazy things with point clouds and transforms and all that kind of stuff that goes pretty deep. But there's a lot of good tutorials on point clouds in our community. This is one I found in the last couple of days, which was really, really good and fast for those with short attention span. It has bananas in it too.
Yeah.
It's also very fun.
So a couple of quick announcements. Is it time now?
Sure.
I mean, we can go back to our conversation, but just I don't want to forget to say this, that as mentioned, we have our 2-day TouchDesigner Berlin event coming up. It is sold out, but we will be live streaming, so I'm going to put those links in the chat here. Day 1 and 2 by the Node Institute is handling all that for us very graciously. There is a music hack space coming up on April 22nd. That's a Saturday. And the topic is going to be Arduino and sensors, I believe.
Yep.
And last but not least, a couple of weeks ago, we launched something that we've been working on for a couple of years with Pseudomagic. And that's our new educational portal at learn.derivative.ca. And if you're learning or teaching, we think it's going to be a really valuable resource for both students and teachers to help sort of streamline lessons and providing a kind of a
bootstrap.
Bootstrap, exactly. And we can just quickly go through it. It's sort of made up of 80 different assets right now. So they're short videos under 10 minutes on a topic. And then and you can basically, I mean, this is the 101. We have only the 101 series right now. That's going to be added to. But you can basically create your own learning path, whether, again, you're teaching or learning. So, and all of these videos come with talks files and some textual information. And we'd love to get everyone's feedback too. Anna, do you think this will be useful for teachers?
I'm so I've been waiting for you to release this since we first talked about this. I'm so excited. I'm teaching in the fall an introductory class at the School of Arts, Media and Engineering because I teach one class in Tempe every year, and that one is called Creating Interactive Media. And it used to be taught on Maximus B, and I'm switching it now to TouchDesigner. And it's an intro class, so I just can't wait. The fact that I can curate my own playlist and give it to the students, that is just so awesome. So thank you. And thank you, Pseudo Magic, for all
Yeah,
this.
exactly.
They're so generous. They're awesome.
So, yeah.
Well,
So,
that
any last thoughts?
yeah.
We could keep going though, right? I mean, I have a question that's just burning, but I'm not going to ask it because it's going to be too long an answer.
Yeah,
No,
I
I'm
would
just
say-
wondering.
Oh, you're wondering? You're gonna?
No, I'm not. I'm not. No, I'm not. I'm
Okay.
not. Next time.
Next time. Well, that we'll make that the topic of the next one. Yeah, thanks everybody for joining in, and thanks Anna for spending the time with us here.
Thanks. Skipping class.
Yeah, well, teaching basically at the same time. Right?
Yeah.
Yeah, this has been so exciting and so fun to work with you, and thank you very much.
Pleasure.
Thank you
Yeah.
so much.
Awesome.
And,
Thanks a lot, Anna. It's been
look
great
forward to
working with you.
our next meetup.
Yeah, can't wait for that.
Hopefully
Yeah.
in person.
Hopefully soon. And you're all invited to here to the Mix Center
Indeed.
anytime.
Would love to see that actually. Yeah, that would be
Yeah.
amazing
Yeah,
to
Please.
yeah.
Please
experience.
come over.
Yeah, we need to organize something.
Yes.
Okay.
And we'll update once we get these files. We'll update with what we do.
Yep.
We'll be in touch soon.
Perfect.
Excellent.
Okay.
Have a good weekend, everyone, and we'll see you. We see you at the next in session.
Yeah, and maybe
Very
some of you would be like, maybe some of you will see actually
In
pretty
Berlin.
soon in person. So have a good evening, and we'll talk
Indeed.
to you soon.
Bye, all.
Bye, everyone.
Bye.